Let me show you how it begins.
Please.
All right, the first term is 0. When you see a new number, the next term is 0. So we saw a 0, but it was the first one. So the next term is 0. We have seen a 0 before. We saw it 1 minute ago. And when you've seen the number before, the next term is how far back? How long ago was it since you saw it? So we saw it 1 step back. So the next term is 1. So now what's the next term? Have we seen a 1 before? No. So the next term is 0. Have we seen a 0 before? Yes. How long ago? 2 steps ago. So the next term is 2. We've not seen a 2 before, right? So we get a 0. And we have seen a 0 before. It was 2 steps ago. And we have seen a 2 before. It was 2 steps ago, so we get another 2. And we have seen a 2 before. It was 1 step ago. Now, for the first time, something really interesting is happening. We have seen a 1 before, but it was 1, 2, 3, 4, 5, 6 steps back. So we get a 6. And we haven't seen a 6 before, obviously. So the next term is a 0. Well, we've seen a 0 before, and it was 1, 2, 3, 4, 5 steps back, so we get a 5 for the first time. So the next term is a 0 again, and then we get a 2. And
well, this is the Van Eck sequence generator, and I apologize for repeating what the gentleman from Numberphile said, but I wanted to write the program myself, so that's basically what it is. The Van Eck sequence was only discovered about 2010, 16 years old. Let's get going with it. So we said we always start with 0, and if that is a new number, well, yeah, it's brand new. It's a new number. Write it next. And so we did. And now we've got a 0 to look at. If that's not a new number, count the number of digits since it last appeared and write that. Well, it last appeared 1 digit ago, so we write the 1. If that is a new number, write a 0. And indeed, it's the first time we've seen 1, so write a 0. If 0 is not a new number, count the number of digits since it last appeared and write that. Well, it last appeared 1, 2 digits ago, so we write a 2. If 2 is a new number, write a 0. Well, 2 is a new number. We haven't seen it, so we write a 0. If 0 is not a new number, count the number of digits since it last appeared and write that. Well, 2 is not a new number, so, now wait a minute. If 0 is not a new number, count the number of digits since it last appeared. Well, 0 last appeared 1, 2 digits ago, so we write a 2. If 2 is not a new number, count the number of digits since it last appeared and write that. Well, 2 is not a new number for sure, and it last appeared 1, 2 digits ago, so we write a 2. If 2 is not a new number, and it's not, obviously, we got 3 of them, count the number of digits since it last appeared and write that. All right, so we'll count the number of digits that last occurred 1 digit ago. We'll write 1. If that's not a new number, count the number of digits since it last appeared and write that next. Now it's starting to get interesting because we're working with the number 1, and it only appeared 6 digits ago. 1, 2, 3, 4, 5, 6 digits ago. So we write a 6. If 6 is a new number, write a 0. And of course it is a new number, so we write a 0. And if that is not a new number, count the number of digits since it last appeared and write that next. And 0 last appeared 5 digits ago. 1, 2, 3, 4, 5. There it is, 5, and so on. Now, I made a graph. And what this does is it charts the last time that number was seen. I apologize, this is going too fast. It's going at 60 frames per second. But I'm doing 1,000 of them, okay? So the current index is now 1,000. We've done 1,000. And it was last seen 61 numbers ago, whatever that is. The maximum separation between the numbers was 705, which is right here. So it's pretty much of a linear projection of the separation between the last time we saw any particular number. And that's it. And thank you for watching.